So, hello everyone, myself Anjali Prasad. We are starting with the week 6 discussion session for essentials of topology. So, let's start with the continuous function, that is the pasting lemma. What is it? That let x tau and y tau dash be two topological spaces and x is equals to A union B, where A and B are closed sets in X. Further, let f from a to y and g is from b to y be continuous functions and f of x is equals to gx for all x belongs to a intersection b. Then the functions f and g combine to give a continuous function, that is h from x to y, defined as h of x is equals to f of x if x belongs to a and g of x if x belongs to b. Okay, so basically in pasting lemma, you need to have two topological spaces whose union will give you x, where a and b are closed sets in X. Further, if f is from a to y and g is from b to y, be continuous functions, then on the intersection, you will get the f of x is equal to gx. Okay, then you can form such
Yes.
function h of x.
Hello.
Yes,
Ma'am, is this meeting being recorded?
yes. Okay, now next. Um, Next, the topic was about homeomorphism. So let x tau and y tau dash be topological spaces. Then a homeomorphism between x tau and y tau dash is a function f from x to y such that f should be bijective, f is continuous, and f inverse is also continuous. Okay. So basically for homeomorphism, what do you need? It is bijection and bicontinuous. Okay. If both these conditions are satisfied, then we say that the function is homeomorphism. Okay. Next, if there exists a homeomorphism between x tau and y tau dash, then the spaces x tau and y tau dash are said to be homeomorphic, and it is denoted by x tau homomorphic to y tau dash. Fine. So this is basically the definition for being homeomorphism. Now, next, let's discuss about some theorems. The theorem was given as being homeomorphic is an equivalence relation on the collection of all topological spaces. Okay, so in equivalence class, we can write that in this form. Okay, so x tau is equals to y tau dash such that x tau is homomorphic to y tau dash. Okay, now next, it has been discussed about the open and closed functions. So if you have x tau and y tau dash be two topological spaces, then a function f from x tau to y tau dash is open if image of each tau open set is a tau dash open set. Okay, and it is closed if image of each tau closed set is a tau dash closed set. Fine. So these are the definitions for open and closed sets. Now next is homeomorphism. So homeomorphism in terms of open and closed functions, it can be shown as f from x tau to y tau dash be a bijective continuous function. Then f is a homomorphism if f is open, if and only if f is open, or if and only if f is closed. Okay, so basically we can say that a function is a bijective function is homomorphism if and only if it is closed and open, with also with bijective continuity. Okay, so if the function is bijective, continuous, and open or closed, then we can say that it is a homomorphism. Fine. So is it clear till now? Shall we move to the next topic? Next, closed functions. So let x tau and y tau dash be topological spaces, then f from x tau to y tau dash is closed if and only if f of a whole closure is subset of f of a closure for all a subset of x. Okay, so if this is satisfied, then we can say that f is closed. Okay, now for homeomorphisms, let x tau and y tau dash be topological spaces, then a bijective function f from x tau to y tau dash is a homeomorphism if and only if f of a whole closure is equals to f of a closure for all a subset of x. Okay. So basically, let x tau and if you have x tau and y tau dash be topological spaces, then f from this x to y is a homeomorphism if f of a whole closure is f of a closure for all a subset of x. So by using these two conditions, you can easily prove this. Fine. Now let's move to the next part. So what is open functions? So with respect to such definitions, so let x tau and y tau dash be two topological spaces, then f from x tau to y tau dash is open if and only if f of a interior is subset of f of a whole interior for all a subset of x. Fine. So these were the definitions for open and closed functions. Now let's move to the topological property. So what is topological property? Any property of a topological space is called topological property if it is preserved under homeomorphism. Okay, so if you have a function f from x tau to y tau dash such that f is a homeomorphism, then if you have any property p in x tau, then also if it is satisfied in y tau dash, then we say that p is a topological property. Fine. Next comes connectedness. So let x tau be a topological space. Then a topological space x tau is disconnected if there exists a comma b subset of x such that a is non-empty, b is non-empty, and a and b are open, and a intersection b is empty, and x is equals to a union b. So if all these four properties are satisfied, then we can say that a topological space x tau is disconnected. Okay. Okay, so basically you need to find such subset A and B of X such that these things are satisfied. Now X tau is connected if we can say X tau is connected if X tau is not disconnected. Okay, so if it is not disconnected, we say that it is connected. Again, there is a something for separation. So A and B form separation when A prime intersection B is empty and B prime intersection A is empty set. Fine. So in this case, we say that it is a separation. Now there are some examples, that is Sierpinski space is connected, indiscrete topology is connected, and discrete topology is disconnected. So these might be the examples you have been visited through. So let's move to the next part. So there were some theorems discussed. So first of all, you have a theorem that is a topological space x tau is disconnected if and only if there exists a non-empty proper subset of x which is both open and closed. Fine. Okay, so we say that a space is disconnected if and only if there exists a you can find a non-empty a topological space with quotient topology is connected. Okay, we will come to this. Let me just finish this part. So a topological space is disconnected if and only if there exists a non-empty proper subset of X which is both open and closed. Okay. So if you are able to find a non-empty proper subset which is both open and closed, then it is said to be a disconnected space. Okay. Next, a topological space is connected if and only if X and empty set are the only open and closed sets. Okay. Now, a topological space is connected if and only if every continuous function from x tau to a discrete topological space is constant. Okay, so we can say that a topological space is connected if and only if every continuous function from x tau to a discrete topological space is constant. Okay, we will discuss these questions. Just a minute. So I hope this part, basic parts are clear to you all. So let's move to the first question. So the first question is that let x and y be discrete spaces, then which of the following statements is correct? That is it all functions from one to the other are continuous? Or is it B, that is x and y are homeomorphic if and only if there exists a one onto function from one to the other? Or is it C, that is f from x to y are, okay, just discard this third third one. So just list out which of these conditions is true. So you are saying that option D is correct. So yes, that both these options will be correct. Let's see how. So every function f from xd to yt, that is D is the discrete topology, and we are taking any arbitrary topology tau on y, then it is always continuous, right? You have seen that. So from that, the first option that says that all functions from one to the other is continuous. So this both the spaces x and y are discrete, right? So obviously it will be satisfied. Okay. So all the functions that you take from x to y or either from y to x, it will be continuous function. Fine. Now next, for homeomorphism, this option B says that x and y are homeomorphic if and only if there exists a one onto function from one to the other. So this says that from the first condition you get that the functions either you take from x to y or y to x, that is inverse function, it will be continuous, right? So you got the condition for bicontinuous. Now remains for bijective. So it is given that x and y are homeomorphic if and only if there exists a one onto function. That is, you have a bijective function, and from first option you get that it is bicontinuous. So both the properties for being homeomorphism is satisfied, right? So therefore, x and y are homeomorphic. So option A and B both are correct. Okay. So let's move to the next question. So the second question is, let x be the set of positive real numbers, that is x is equals to open 0 comma infinity. The statement is that the function f from x to x defined by f of x is equals to 1 by x is a homeomorphism from x onto x. So is it true or false? Justified. Is it a homomorphism? So you were asking about option A, as F is bijection and is a continuous map. So yes, true by the definition of homeomorphism, bijective, and F and F inverse are continuous functions. Okay, yes. So F is also continuous and its inverse is also continuous function. Fine. Now let's move to the next question. So the next question is, state whether the following statement is correct or not. So the statement is, the property of being Cauchy sequence is topological. So state whether it is true or false and justify it. You were asking about topological space with quotient topology is connected. So it is not true. You can find its explanation. And the next thing that you asked were about the product of two connected spaces. So yes, if you are taking arbitrary number of products, so the product of the connected spaces is also connected. I have already ticked it. So the correct option is B, that is false. Okay. So how it is true? So what about topological property? So if you are taking the property, let's discuss what is a topological property. So if you are taking F from x tau to y tau dash, so any property P is a topological property if it is satisfied by X and it is also satisfied by Y. Okay. Okay, wait. So if you have F that is a homeomorphism from x tau to y tau dash, then it is a topological property if the property is satisfied in x tau and the same is satisfied by y tau dash. Okay. So here, if you are taking a function from closed interval 0 1 to closed interval 3 5, then and if you are taking a property as length, so is it a homeomorphism? Yes, you can form a homomorphism. So is the property length is a topological property? No, right? Why? Because it is homomorphism, but in both the spaces you can say sets you can say see the length. Here the property is length. Okay, so when you will measure it, so here it is 1 unit, but here it is 2 unit. Okay, so this function is homeomorphism, but the property of length, that is being of 1 unit, is not satisfied. Okay, hence the length is not a topological property, right? You can easily get it from the boundedness. Okay, like if you are taking a function from 0 comma 1 to r, so here it is bounded, but here it is not bounded. Fine. Hence f being a homeomorphism, boundedness property is not a topological property. Fine. Yes. So what you're getting, that from the current question, that is the property of being Cauchy sequence is topological. So it is not true. It is false. Fine. Why so? Because if you are taking, let x be the set of positive real numbers, that is x is equals to 0 comma infinity. So the function f from x to x defined by f of x is equals to 1 by x. Okay, if you are taking a set of positive real numbers x and you are defining a function from x to x by f of x is equals to 1 by x, then it is a homeomorphism from x onto x. How? You can simply check that it is a homeomorphism. Now let's see for the Cauchy sequence. Okay, now if you are taking a sequence an as 1 comma 1 by 2 comma 1 by 3 dot dot dot, then this sequence is a Cauchy sequence, right? But the corresponding function that is corresponds under the homomorphism to the sequence, this corresponds to sequence of f of an, right? Now this will be what? Sequence of 1 2 3 dot dot dot. Now this sequence is not Cauchy, right? So you have got a sequence which is Cauchy, but its image is not Cauchy. Fine. The sequence an is Cauchy sequence, but the sequence f of an is not Cauchy. Hence, the property of being Cauchy sequence is not topological. Fine. Because in in the domain you are getting a Cauchy sequence, but in codomain the being Cauchy sequence is not preserved. Okay. So hence the property of being Cauchy sequence is not topological. Fine. So let's move to the next question. So consider the projection mapping pi from R2 to R of the plane R2 into the x-axis, that is projection of x comma y is equals to x. Then the projection mapping pi of x then the projection mapping pi is uh, just let me know which is the correct option. Is it option A, that is open but not closed, or is it option B, that is closed but not open, or is it option C, that is both open and closed, or is it option D, that is none of the above? Okay, so you need to justify that which of these options is correct. You were asking about is there any link between separable spaces and connected spaces? Saying that both open and closed. Just check. Just check it. Is it both open and closed, or is it something else? Open, but what about closeness? If it is open and not closed, then just find one counter example. So you're saying option C is correct. Let's see it. So here the correct option is A, that is open but not closed. Why so? So let's see it from the graph. So if you are having open set G subset of R2, okay. Now if you are considering this open disk D, fine. So you need to find its projection on R, right? This D is in R2, you have to find its projection on R. So when you will take its projection, you will get such open interval, right? So its projection is given by pi of this D. Okay. So for any point P, it will be pi of P. Fine. So basically, if you are taking any open set, so its image is again open. You can see that. Okay. So under projection mapping, the image of a open set is open. Okay. So observe that the projection pi of D of any open disk D subset of R2 is an open interval. Hence, any point pi of P in the image pi of G of an open set G subset of R2 belongs to an open interval, right? Which is contained in pi of G, or pi of J is open. Fine. So accordingly, we get that pi is an open function. Fine. Now we have a contradiction for what is the okay, let me just complete it. So now for closed function, closed, it is not a closed function. Why? So just consider this set A that is given by this tuple x comma y such that xy is greater than equal to 1, such where x is greater than 0 is closed. Okay. But its projection, so if you are taking the set A, so how it will look like? Its graph will be given this. Okay. So what is xy is equals to 1? It is given by y equals to 1 by x. So you will get this graph, right? Now if you will take its projection, so what you will get? So its projection on this R, you will get open 0 to infinity. Fine. Now this set A, what is this set? It is xy greater than equal to 1. So this set is closed. Why? Because its complement is open. Okay. Now this set is closed, but its image, what are we getting? Its projection we are getting 0 to infinity, which is open. Okay. So here, the image of a closed set, we are getting an open set. Fine. Therefore, this function, this mapping pi is not a closed function. Okay. So I hope it is clear to you. You are asking about what is the projection of a circle on the x-axis. What is the projection of a circle? Are you taking the like closed? Like, are you including its boundary also? Okay. So if you take its boundary also, then you will get a closed interval, right? If you are taking this disk D, yeah, you are asking about circle, right? So these points are lying on circle, right? These points. Yeah, circle in usual sense. You are taking this circle, right? So circle is having these points, right? These points, these points are given by x comma y. Only 0 and 1 means. Okay, if you are taking this, yes. If you are taking this circle, okay, so you are get this endpoints, its projection. You are correct. So you will get this points A and B as its projection. Okay. And then again, it should be mentioned, right? That circle, how that circle lies. If that circle lies in this plane, then you will get these points, right? You are saying A and B if it is 3D, right? If it looks like a plate that's coming out of the screen, then only you are getting these 2 points, right? But it is in this plane on this paper on the screen. Yeah, in R2, but where it is placed on this screen, right? This screen is R2, right? Now, if you are taking its projection on this line, real line, so what it will be? It will contain all these points, right? Yes, so it will contain the whole interval AB. So basically, you should be clear with that where your circle lies, because if you are taking it like on the z axis, then it will be on zy axis, right? So the axis should also be mentioned for that, for taking the projection. Fine.
And what is the projection of the disk?
For this,
Closed disk.
huh?
Project, projection of the closed disk.
Closed disk will be this closed interval.
Again closed interval.
Huh?
Again closed interval.
Yes.
Projection of the circle is closed interval and projection of the disk is again closed interval.
Yes,
Both are
yes,
same.
yes.
Okay.
Why? Because, see, if you are taking this point, okay, here, this point P, right? इसका प्रोजेक्शन यहाँ पे आप एक लाइन बना लो, ठीक है? इस पॉइंट P पे भी आपको यही प्रोजेक्शन मिलने वाली है। इस लाइन पे हर पॉइंट के लिए ये कैसा दिखेगा? इस लाइन पे हर पॉइंट के लिए इसकी वैल्यूज कैसे
हर एक
दिखेंगी? मान लो
एक ही जगह पर।
ये किसी पॉइंट बी पे आ रहा है, ठीक है? तो ये
यस
कैसा
मैम।
दिखेगा? बी कॉमा कुछ वाई होगा, राइट? तो इस लाइन
हाँ।
का हर एक पॉइंट किस पे मैप करेगा? बी पे।
यस मैम।
सिमिलरली आप यहाँ एक लाइन ले लो जो मैप कर रहा है, मान लो किसी एक पॉइंट बी डैश पे। तो यहाँ का हर एक पॉइंट किस पे मैप करेगा इस लाइन का? बी डैश पे। ठीक है?
यस मैम।
तो इसी तरह से डिस्क का भी पूरा क्लोज इंटरवल ए भी आएगा। और अगर
सपोज
आपसे
मैम, सर्कल अगर सपोज आधा उसमें मतलब एक्स एक्सिस में है, आधा
हम्म
अगर ऊपर नीचे है,
मतलब आप थ्री
एक्सिस
डी में
जो है
बात कर रहे हो?
सर्कल की नहीं। हाँ, 3D में ही करना पड़ेगा।
हाँ, थ्री डी में कह रहे हो ना, ऐसा दिखेगा, राइट?
नहीं, इसकी एक्सिस जो है मतलब उसमें होनी चाहिए, डायमीटर कोई एक्स एक्सिस में लाई करे।
हाँ।
इसका जो ओरिजिन है, मान लीजिए सेंटर जो है वो उसमें लाई करे एक्स एक्सिस में,
हम्म।
तब फिर प्रोजेक्ट।
मतलब कुछ कहना चाहते हो इसके बारे में?
मैं कह रहा हूँ कि सपोज ये जो सेंटर है सर्कल का,
हम्म।
वो एक्स एक्सिस लाई करे,
अच्छा अच्छा,
फिर
मतलब
उसके
ऐसे।
तब।
ओके। तो ऐसे कह रहे हो कि इस तरह से है, इसका सेंटर एक्स एक्सिस पे लाई कर रहा है, ठीक है? तो
यस
इस
मैम।
केस में प्रोजेक्शन आपको ये दो पॉइंट्स मिल जाएंगे ना?
हाँ, ये डिपेंड करेगा ना प्रोजेक्शन आप किस साइड से ले रहे हैं, मतलब ये तो
हाँ, मतलब
वही
आप
बात
स्पेस कौन सा
लेगा।
ले रहे हो, आपका फंक्शन मतलब डोमेन कहाँ है, वो डिपेंड करेगा, राइट?
हम जो प्रोजेक्शन है वो नेचुरली ज्योमेट्रिकल सेंस में डिफाइंड होते हैं क्या?
हाँ, बेसिकली वो
प्रोजेक्शन
ज्योमेट्रिकली डिफाइंड होती है प्रोजेक्शन।
यस मैम,
आप
जैसे
जैसे
हम लोग
कैलकुलस
टॉर्च।
में भी जब हम ट्रिपल इंटीग्रल्स के लिए भी प्रोजेक्शंस निकालते हैं ना।
यस मैम,
हम्म।
उसमें तो डायरेक्शन कंसीडर करते हैं हम लोग,
हाँ हाँ,
यूनिट
रीजन
आउटवर्ड
मिलता
में।
है आपको, राइट?
यस मैम।
हम्म। तो सिमिलर ही है।
ओके मैम। ठीक।
ओके, सो लेट्स मूव टू द नेक्स्ट क्वेश्चन. State whether the following statement is correct or not. So you have the question that area is not a topological property. So is it true or false? Is it option A or option B? So it is option A. As we discussed earlier about the topological property, so it might be quite obvious that the area is not a topological property. Okay, so option A is correct. So how we can prove it? That consider open disk D is equals to this set r comma theta such that r is less than 1 with radius 1 is homeomorphic to the open disk D star is equals to r comma theta such that r is less than 2. Okay, with radius 2. In fact, the function f from D to D star defined by f of 2r comma theta, r comma theta to 2r comma theta is a homeomorphism. Okay, so basically here you can see that we can define the homeomorphism between these two disks, but the area of this is not preserved, right? Hence, the area is not a topological property. Fine. So I hope it is clear.
And,
It was true. Huh?
and any two-dimensional figure are homeomorphic to each other.
Any we cannot say.
Like if I ask rectangle and circle
Yes, it is
are both,
homeomorphic.
how can
You can deform
we
it, right?
form it?
Okay.
Merely seeing, can we say anything about homeomorphism between two figures? Merely seeing.
Yeah, but like if you can deform it without like in the first lecture itself, in the introduction, sir might have told you about that. If without crossing and all, if you can deform it, the shape, then you can say that it is homomorphism.
Continuous deformation.
Yes, continuous deformation.
Okay.
Okay. Shall we move to the next question?
Yes, ma'am.
So the next question is consider the following intervals on the real line R such that A is equals to 0, comma 1 and B is open interval 1, comma 2 and C is close to and open at 3. Then let me know which of these following options is correct. Is it option A, that is A and B are separated sets, or it is option B, that is B and C are separated sets, or option C, that is A and C are separated sets, or is it option D, that is B and C are not separated sets? So try it.
I am according to you, any two human beings are homeomorphic in topological sense.
Um, okay, we will discuss it later.
Ma'am, please
Huh?
show the definition.
Huh?
Please show the definition.
Okay.
Please show the definition of
Let's see the explanation. So the correct
please,
option will.
please please show the definition of the separated sets.
Okay, okay. So what is separated sets? So two subsets A and B of a topological space X are said to be separated if when we say that it is separated, that it should satisfy two conditions. First is that A intersection B should be empty. Then second is that A intersection B closure should be empty and B intersection A closure should be empty. Fine. So when we say that the two topological spaces are separated, if we get two subsets A and B such that its intersection is empty and it satisfies this property, that is, the accumulation points of B is not a member of A and accumulation point of A is not a member of B. Fine. So basically you can um, so see here that A closure, you have set A that is 0 comma 1, set B that is 1 comma 2, and set C that is close 2 and open at 3. Fine. Now taking closure of A, what you will get? Close 0 comma 1, then B closure is, it will be 1 comma 2, then C closure it will be close 2 comma 3. Fine. So now if you are first checking for A and B, so A closure intersection B will be what? Empty. And A intersection B closure will be empty. Fine. So A and B are separated. Fine. Similarly, we can check for B and C. So what we'll get for B closure intersection C, it will be 2, right? It is non-empty. Hence B and C are not separated.
Clear.
Now, okay. Now let's check for A and C. So A closure intersection C is empty and A intersection C closure is empty. So A and C are separated sets here. Fine. So by the definition, you can see that these options A, C, and D are correct. Fine. The option that B and C are separated sets are is incorrect. Fine. So I hope it is clear to you. Let's move to the next question. So the next question is the statement that is the real line R with the usual topology is a connected space. Okay. So justify it. Is it true or false? So you are saying that the correct answer is option A, that is the real line R with the usual topology is a connected space. Please justify it because we need to say that it is connected space. That is, by the definition, we have to prove
Then
that it is not
we
disconnected, right? So how we will prove that it is not disconnected?
assume R is connected. Then there exist two open sets such that R is union of A union B.
Okay.
A and B are open, hence A union B is also open. Meanwhile, R is closed as well, but A union B cannot be closed. So there is contradiction like this.
Okay. How we will say it about discontinuity or continuity, sorry, disconnected set or connected set?
There is no set which is both open and closed.
Okay, so you don't get any proper subset of R such that it is both open and closed. Okay, so by that you can say that it is a connected space. So yes, it is true.
My explanation is not good.
What? Okay, let me
That
just explain
assume
it.
R.
Let me just explain it, then we will see to it. So a topological space X is connected if and only if, when we will say that it is connected, if X is not the union of two non-empty disjoint open sets. Fine. Or equivalently, we can say that X and empty set are the only subsets of X which are both open and closed. Okay. So in that case, we will say that the particular space is connected. So here you can see that R comma tau e, that is real line with the usual topology. Here we cannot find any subset A of proper subset A of R such that it is both open and closed. How we can prove it? That if you are taking open subset A comma B, proper subset of R, then is it closed also? No, right? Why? Because it's complement, that is minus infinity to closed A and closed B to infinity, is not open, right? So we cannot say that this is closed in R with usual topology, right? Hence, the only only subsets which are open are R and empty. Fine. So in that manner, we can say that it is a connected set, connected space. So for proving that a particular space is disconnected, it is sufficient to prove that you, like for disproving, you can find any proper subset such that it is clopen, then you can easily say that the set is disconnected. Okay, fine. Now what you were asking about?
No, ma'am, clear. There is no question.
Okay. Okay, shall we move to the next question? Yes. So if A and B are two non-empty separated sets, then you have these options. So check which of this is correct. Is it option A, that is A intersection B closure is empty and A closure intersection B is empty? Or is it option B, that is A union B is connected? Or is it option C, that is A union B is disconnected? Or is it option D, that is both A and C? So check it and let me know which of this is correct. So you are saying that option D is correct. So yes, the correct option is D, that is both A and C. Because by the definition itself, you will get that is it, if it is separated sets, then A intersection B closure is empty and A closure intersection B is empty, right? Next thing, A union B is disconnected, right? So let's prove that it is disconnected. For proving disconnectedness, you should have two sets, right? So let us consider G, two non-empty sets, G as complement of B closure and H as complement of A closure. Fine. So here, if you can see that it is complement of a closed set, so G and H are open. Fine. Now you need to prove that A union B is disconnected, right? So for proving it is disconnected, just taking its intersection with G, what you will get? A. Now, if you are taking A union B intersection with H, you will get B, right? So basically,
How A union B intersection G is equal to A? Please explain.
what is this? A union B intersection G. What is G? B closures complement, right? So A intersection B closures complement union B intersection B closures complement. What you will get? Sorry, here A intersection B closures complement.
That is correct, ma'am.
Huh?
That was correctly written.
Oh, sorry, yeah. B.
Union.
Yeah, yeah, it is B union B intersection B closures complement. So what you will get? Just check it what you are getting.
मैम नीचे गलत दिखा है आपने.
ओ बी आएगा यहाँ पे. क्या आ रहा है इसका आंसर?
B intersection B close complement. ये इधर से एम्प्टी सेट आ जाएगा. B intersection B closure complement.
तो यहाँ पे क्या मिलेगा? बी क्लोजर का कॉम्प्लीमेंट में ए तो आएगा, राइट? ए और उससे ज्यादा आएगा, राइट? यही होगा.
इंटरसेक्शन B क्लोजर एम्प्टी है ना, वहां से देख सकते हैं.
यहाँ देखो, अगर आपके पास ए है और बी है, राइट? तो बी का, ये बी है, बी का क्लोजर मान लो यहाँ तक आ रहा है. ओके. सो बी क्लोजर कॉम्प्लीमेंट में ये पूरा पार्ट आ जाएगा. उसका इंटरसेक्शन आप ए के साथ अगर ले रहे हो तो एटलीस्ट ए तो मिलेगा ना.
ठीक है ना.
हाँ.
वी हैव टू यूज A इंटरसेक्शन B क्लोजर एम्प्टी. ये वाला हमें यूज करने पड़ेगा तब ये बोल पाएंगे, नहीं तो हो सकता है कि वो क्लोजर उसका ए को भी थोड़ा बहुत कंटेन कर रहा हो. तो अगर कॉम्प्लीमेंट
नहीं नहीं
निकालेंगे
नहीं
तो
नहीं,
वो
हमें
ए.
वो नहीं चाहिए ना. वो कंटेन कर रहा हो तो कर रहा हो, कोई बात नहीं. हमें तो ये इक्वल टू क्या मिल जाएगा? ए मिल जाएगा, राइट?
कंटेन अगर ए को करेंगे तो कॉम्प्लीमेंट से बाहर हो जाएगा ना मैम. कॉम्प्लीमेंट अगर लेंगे, बी क्लोजर का कॉम्प्लीमेंट यदि निकालेंगे और
हाँ.
वो ए का कंटेन कर रहा है सपोज, बाहर नहीं हो जाएगा उसको कुछ.
ए इंटरसेक्शन पर ए इंटरसेक्शन बी क्लोजर तो एम्प्टी है ना, वो तो यूज करो.
वही
वो
तो कह
यूज
रहा हूँ
कर,
उसको
हाँ, वो
यूज.
यूज करना पड़ेगा. क्योंकि यहाँ पे आपको बी क्लोजर और ए के बीच में क्या रहेगा? हमेशा एम्प्टी रहेगा, राइट? हाँ, ये यूज करना पड़ेगा. सो फिर उसके बाद आपको ये मिल जाएगा कि ए इंटरसेक्शन बी क्लोजर का कॉम्प्लीमेंट आपको ये मिलेगा, राइट?
यस मैम. क्लियर.
ठीक है. सिमिलरली यहाँ पे भी हो जाएगा. ठीक है.
यस.
सो fine. So you got two non-empty disjoint sets whose union is A union B. Fine. Thus G and H form a disconnection of A union B, and so A union B is disconnected. So I hope it is clear. Shall we move to the next question? Okay. So these were the questions for the current session. So let us discuss some questions that were posted. So you were asking about the inverse mappings, right? So how to find the inverse images? So let us discuss about it. So if you have function like given like h of x is equals to x minus 2 and x plus 2, if x belongs to minus infinity to 0, that is x minus 2, and it is x plus 2 if x belongs to close 0 to infinity. Fine. So now um, if you are taking the inverse, for taking the inverse, let us just find its like graph. So if you're plotting it in the inverse manner, what you will get, f of y is equals to x, that is equals to y plus 2 for minus infinity to minus 2, and it will you will get it as y minus 2 for close to infinity. Fine. So here how you are getting, just put here y is equals to x minus 2, so you will get y plus 2, and it is up to 0. So if you are putting here 0, so you will get minus infinity to minus 2, and for close 0 to infinity, if you are putting it here 0, then you will get it as close to infinity. Fine. So this will be the inverse function that you will get. Now if you have been given, so if you will plot it, you will get a graph like this. Okay. So now you need to find.
Ma'am, this is not always feasible to draw a graph. Without graph, how could I find the inverse image of the function?
If it is on R, you can try with the graph.
If not,
If the function that we are describing, if it is on R,
yes.
then you can obviously draw a graph. Leave it. If you are not able to find the graph, then also you
You
can.
draw a graph of x square plus under root x.
Uh-huh.
X square plus under root x. What is the graph of x square plus under root x?
Okay, you are saying that if you are getting a complicated function, okay, then you are not able to plot the graph.
And what should be the procedure of finding inverse image
Okay,
of a
just go
certain
by
function?
the definition. So if you are taking the open set G, that is open interval 1 comma 3, right? So what is the definition for finding the inverse image? So H inverse of G is given by the set X belongs to R such that H of X belongs to G, right? So here you are taking a set X belongs to R such that H of X belongs to G, that is the open set 1 comma 3, right? So basically you need to find all that X belongs to R such that its image, that is H of X, will belong to this interval. Okay. So I don't think you will get such complicated like functions, so that you will find it difficult to get this part. Okay. You need to find, actually collect all those X such that its image will enter this open interval 1 comma 3. Okay. So here our graph is looking like this, right? Minus infinity to this point. Here it is open at minus 2, and here it is from close to infinity, right? Now if you are taking the inverse image for 1 to 3, how it will look like? So for 3, you can see that it is open at 3, so you will get at 1, right? It is cutting at 1 here on x-axis, so you will get open at 1. So now what about the this side. So here you can see that you are getting images up to this part, right? Up to 0. Fine. So for x equal to 0, you are getting your image in between this interval 1 to 3, right? So in that sense, if you will collect all these x, so you will get the interval as close 0 and open at 1. Fine. So in this manner, you can find the inverse image. Okay. So in the similar manner, we can discuss about the question in the last session that we are stuck upon. So we had a question that consider function f from R to R defined by f of x is equals to x minus 1 if x is less than equal to 3 and it is half times x plus 5 if x is greater than 3. Okay. Then which of the following options is correct? Is it option 1, that is inverse image? So basically in this question we were stuck upon finding the inverse image, right? So the option was it is the inverse image of every open set is in codomain is open in domain or and f is continuous. Okay. So when we plot it, we got a function like this. So here we can see that f of x is what? X minus 1 if x less than equal to 3 and it is half times x plus 5 if x is greater than 3. Okay. So if you are taking its inverse function, so how we will get it? So if you are putting y is equals to x minus 1, so you'll get x is equals to y plus 1. And if you are putting y is equals to half times x plus 5, then you'll get 2y minus 5 is equals to x. Okay. So basically you will get x is equals to y plus 1 if y belongs to minus infinity to close to. And it will be 2y minus 5 if y belongs to open interval 4 to infinity. Fine. So basically you got this function x as y plus 1 if y belongs to minus infinity to close to and 2y minus 5 if y belongs to open interval 4 to infinity. Now the statement says that the inverse image of the open interval 1 comma 3 is the open closed interval 2 comma 3 which is not an open set. How we will justify it? So see here, if you are taking, so how this graph lies from, like, it is up till 3, then it is from 4 to infinity, open 4 to infinity, right? Now you have to consider this open interval 1 to 3. Now if you will take its inverse image, what you will get? So basically you need to collect all the x on the this real axis such that x-axis such that its image lies in between this interval 1 to 3. Okay. So which are such points here? Which points you are getting? So at this point, that is at open 2, at open 1, you will get it as,
Open one, close three.
okay. So at open interval 1, what you will get it as open at 2, right?
Hmm?
Now, okay, for 1, you will get the inverse as, it will be closed at 2, right? So for 1, you are getting it as 2. Now, for 3, you need to find the elements in x, x belongs to R on x-axis such that its image lies in between 1 to 3. Okay. Now, if we are moving in this direction upwards, like after this point 3, you're not getting any image, right? Like the maximum you are getting up to 3. So all the images, sorry, the pre-images for 1 to 3, you are getting in between open 2 to close 3. After 3, you are not getting any point. Okay, which is image, which is forming an image. Fine. So in that sense, you just need to collect all those x belongs to R such that the image of that x is open interval 1 to 3. So you will get open interval 2 to closed at 3, right? So the statement is correct. I hope it is clear now. Okay. Okay, so do you have any other doubts that need to be discussed?
तरफ से next you want to tell us.
Okay.
Ma'am, is separable space connected?
Huh? Is separable spaces connected? You are asking about.
Yes.
With respect to separatedness definition, you are saying?
If there exists countable tensor,
Huh. So will it be connected? You are asking.
yes, ma'am. Means
It's
discrete topology is not connected, no, ma'am.
discrete.
Discrete topology is not connected.
Uh, is it disconnected?
Yes, it should be discrete.
Huh. How you
As
will prove
A,
that? How you will prove that?
if you take A, the subset of X, and
Hmm.
A complex, then both are open, intersection is empty, and union is X. So it forms a separation for X.
Hmm.
That's why it is connected, hence not.
Any other method to prove that? Prove that discrete space is disconnected?
There does not, there exists
Hmm.
clopen, proper clopen, non-empty proper clopen set.
Hmm.
Then it is this. So every set of X in discrete topology is clopen.
Hmm.
Hence,
So you will get any like any proper subset which is open, right? So yes, discrete spaces
we
disconnected.
take discrete, we take discrete topology on an uncountable set. Then it is not separable.
Pardon?
If we take discrete topology on an uncountable set, then it is not separable.
Separable space.
Yes, ma'am. Separable space.
Hmm. Okay. How will you prove that?
There does not exist any countable density.
Okay. Yes, so by that you can prove that. So what about separability and connectedness? Is there any connection between separable spaces and connectedness?
I don't find any. If you can explain, then it will be good.
Okay, I'll search, I'll see for it, and you can also see that is there any connection between separable spaces and connected spaces. Okay. I hope the pasting lemma is
Ma'am,
clear to you all.
ma'am, in terms of open sets, can you explain testing lemma?
It is there, the definition for pasting lemma. Same, like here it is for A and B are closed sets. It can be proved similarly for open sets also. That if A and B are open sets in X and X is A union B, such that F is from A to Y and G is from B to Y, then it is continuous function. So you can form such H from X to Y in this manner. Uh,
Yes.
I hope the definition is same for our open sets also, the pasting lemma.
We replace A and B are open sets.
Huh. And also for homeomorphism, we just saw that the only properties that we need to satisfy that it is bijection and bicontinuous. That is the basic definition for homeomorphism. And if by another method you want to prove, then it is sufficient to prove that the function is bijective, continuous, and either open or closed. Okay, then in that manner also we can prove the homeomorphism. I guess next lectures are also on connectedness, right?
Yes, ma'am.
So there will be more examples discussed on connectedness. And I hope it is clear what is the topological property, why length is not a topological property, or boundedness or area or any such geometrical properties are not a topological property. Okay. So basically you need to find a property here which is satisfied by this space, but it is not satisfied in this space. Okay. Under the homeomorphism. So that property will not be that property. We will say that it is a topological property. So that doubt is clear to you, right?
Ma'am, can we talk about continuity as a topological property?
Yeah.
Being
Yes. Yes.
universe
Yes.
is a topological property.
Huh.
Being continuous is a topological property.
Okay. Define how you are thinking about it.
I'm asking to you.
Yeah. You are asking. Just I know. I want to know your thoughts about it. Like what
If
you
we
are
take
thinking.
any, if we take any topological space which contain functions, continuous functions,
Homeomorphism.
then homomorphism.
We are taking F homeomorphism, right? And you are taking
No,
any continuous function. How?
if we are taking a topological space which contains functions,
X is a set of functions.
yes, ma'am.
Continuous functions.
Yes, ma'am. Continuous functions.
So you will have to take X as set of continuous functions, right? So have you
Yes,
seen
ma'am.
any such topological space? Like it will be there, but have you come
Can
across?
we such such topological space? Can you define such topological space?
That's what I am asking to you. I haven't came across any such topological space where X is a collection of continuous functions and tau is defined on that.
We define topologies on GLNR, SLNR, like
Mm-hmm.
general linear.
Okay, just a minute. Yes, there are topologies on continuous function. So you can go through that. So if you have topology with a continuous function, so you will take it take. So it has already has that property, right?
So, मतलब being continuous is a topological property.
Okay, we will have to justify it, right?
Yes, ma'am. I think composition से हो जाएगा.
कैसे?
अगर F हमारा वहाँ होम्योमॉर्फिज्म है F, तो हम उसको ऐसे कुछ डिफाइन करें f of h is equal to composition में डिफाइन करें composite f करके.
Hmm.
Where h is continuous and f is homeomorphism, then f composite f is also continuous. इस तरह से ये
मतलब इसमें हमें प्रॉपर्टी लेनी पड़ेगी ना कि कंटिन्यूटी प्रॉपर्टी इसकी है.
हाँ एक मतलब फंक्शंस तो हमें लेने ही पड़ेंगे ना, तभी तो कॉन्टिन्यूटी की बात करेंगे. कोई ऐसा टोपोलॉजिकल स्पेस जिसमें जो एलिमेंट्स है वो फंक्शंस हो,
हम्म.
भी तो बात कर पाएंगे.
ओके. नीड टू सी अबाउट इट.
हाँ मैम, जीएलएनआर के ऊपर कोई टोपोलॉजी हम डिफाइन कर सकते हैं.
किसके ऊपर?
जीएलएनआर
डिफाइन कर.
जनरल.
डिफाइन डिफाइन करो.
मैं पूछ रहा हूँ आपसे.
क्या आप डिफाइन करके देखो. इफ यू आर गेटिंग, वी विल डिस्कस.
मैम इस पे तो क्वेश्चंस भी मतलब पूछे जाते हैं काफी, मैंने सुना है कनेक्टेडनेस जीएलएनआर पे और एसएलएनआर पे.
हाँ.
प्लीज थोड़ा सा आप देख
ठीक है,
लीजिए.
हम देखते हैं इसके बारे में. ठीक है.
यस मैम. एमबीए में आते हैं.
फिलहाल दिस सेशन इज अबाउट एनपीटीएल, राइट?
मुझे लगता है एनपीटीईएल में थोड़ा सा और डेप्थ में जाना चाहिए.
But
मतलब जैसे
there are
आईआईटी.
more, there are lots of students now who are starting with basics and they just want to know basic knowledge. They are not looking.
बेसिक बेसिक ठीक है, पर उसमें थोड़ा जब अब सपोज बेसिक हो गया तो थोड़ा सा उसको और इनहेंस करना चाहिए सब्जेक्ट को.
You are done with the basic, na? Others may have not.
No, I am not saying that you should not taught teach basics, but I am saying that some advanced subject must be included.
ओके, सो देर माइट बी सम, जैसे कि कह रहे हैं कि एडवांस कोर्सेज भी है राइट टोपोलॉजिकल, ये एसेंशियल्स ऑफ टोपोलॉजी, एसेंशियल्स में बेसिक्स के ऊपर चल रहा है राइट, ये कोर्स।
हम्म।
सो देर माइट बी
अच्छा।
कोर्सेज जो एडवांस पे कर रहे हैं राइट, सो आप उस पे देख सकते हो राइट।
अच्छा अच्छा। ओके मैम।
ठीक है, इफ यू डोंट हैव एनी डाउट देन यू मे लीव।
And can we discuss about product of two connected spaces?
हाँ, product of two connected spaces, what it will be?
Mm. As you told, connected.
It will be connected right.
Yes,
It
ma'am.
is proven that if you are taking arbitrary product of connected spaces, it is again connected.
Ma'am, what connectedness geometrically mean?
What disconnectedness geometrically means?
Yeah, whatever connected or disconnected.
हाँ, तो disconnectedness क्या है कि
मतलब
आप,
एज यूजुअल सेंस की डिस्कनेक्टेड मतलब अलग अलग कुछ कर सके हम।
हाँ, लाइक सेपरेबल होने चाहिए, आपको दो सेट्स मिलने चाहिए ए और बी जो सेपरेटेड हो।
मैम जस्ट सपोज एक पॉइंट हम निकाल लेते हैं किसी डिस्क से सपोज,
हम्म।
तो वो कनेक्टेड मतलब कुछ लोग वो पाथ वाथ ज्वाइन करके बताते हैं कि वो लाइन
हाँ,
ड्रॉ
तो
कर सकते
वो
हैं तो।
सब दैट थिंग यू विल स्टडी ना इन लोकल कनेक्टेडनेस, पाथ कनेक्टेडनेस,
यस मैम।
दिस थिंग्स आर
तो
आल्सो
फिर
देयर राइट।
डिफरेंट मतलब इनसे।
हाँ हाँ, इट इज डिफाइंड फॉर
We
पाथ
don't-
कनेक्टेडनेस, ऐसा है ना कि इफ यू हैव अ open set, so if you can take any 2 points and you can join it with the path, these 2 points, then this set will be path connected. Okay,
yes,
तो इस तरह से पाथ कनेक्टेड से भी आप डिफाइन कर सकते हो। तो पाथ कनेक्टेडनेस, फिर लोकल कनेक्टेडनेस है कि एक पॉइंट के पास कनेक्टेडनेस चेक कर रहा है।
yes ma'am, yes ma'am.
तो these are the topics which will be covered in upcoming weeks. I guess next week you will be getting through these problems. Epsilon net metric space, क्या बोलना चाह रहे हो आप?
He's
Epsilon not
asking about
definition, epsilon not definition metric spaces में for continuity,
totally disconnect.
totally disconnected. Okay, so I guess for that something using convergence they can define for epsilon naught. टोपोलॉजी में शायद आई डोंट नो बिकॉज मेट्रिक स्पेसेस में तो है, टोपोलॉजी में तो इतने
मीटिंग
ही डेफिनेशंस है अभी। हाँ
स्पेसेस जो होंगे तो उसमें तो फिर कर सकते हैं ना।
हाँ हाँ।
तो मीटराइजेबल स्पेसेस जो
हाँ,
होंगे उसमें फिर।
मेट्राइजेबल टोपोलॉजिकल स्पेसेस में होगा, बट इन जनरल टोपोलॉजिकल स्पेस में नहीं बता सकते राइट, क्योंकि वहां पे डिस्टेंस वाली बात नहीं आती है। सो यू, ओके, so thank you for your patience and for joining the session. If you have any other doubts we may discuss. or you may leave the session. Okay. Thank you for joining. We will meet in the next session. Okay. Thank you. Okay.
प्रॉब्लम्स कम थी और ज्यादा होनी
हाँ हाँ।
प्रॉब्लम्स
क्या प्रॉब्लम्स?
मतलब कम प्रॉब्लम्स थी और थोड़ा प्रॉब्लम्स इंक्लूड करिए
Okay, okay, okay. I'll try from the next time that I'll add up more and more problems. Okay.
अब जा रही
Okay. I hope you don't have any doubt.
यस
Thank you for joining.
When product of two materializable species are linear.
Huh?
Product of two materializable species is also materializable.
Product of two metrizable spaces is also metrizable. Okay, we need to prove this. होगा ना?
So, the design करनी पड़ेगी
क्या चीज?
होल्डिंग तो मैट्रिक डिफाइन करनी पड़ेगी ना
हाँ, मेट्रिक स्पेसेस आपको डिफाइन करनी पड़ेंगी और उसके हिसाब से प्रोडक्ट. Do you have any?
दिखानी
Do we
पड़ेगी कि
have
वो
any
ऐसा
any such result?
don't know my I was just asking clarification.
So it is there, but you need to find the proof of it. It is true. You have its
It's
proof
true.
also.
For arbitrary product, it is true.
Mm, for finite.
Okay. Okay, man. There are so many questions which are not not covered.
You can post it on the discussion forum. You get answers there, right?
Yes, sir.
You have
Only
also posted about, I guess, for length. So I'll post its answer over there. And rest, I guess, other options have been clear, right?
yes, sir.
Okay, so is there any other doubt?
Now, is there any relation between first countable spaces and connectivity.
I need to see all that. I need to see.
Is there time left? Okay,
Huh?
ma'am.
Okay. What?
Is there time left
Okay. Okay.
for
Okay.
questions? Sure.
So if all the doubts are clear, so we will meet in the next class. Thanks for joining. Okay.
Okay, ma'am. Thank you.